Sketch each of the following stating their domain and range. Well, if we look at this one, y is equal to mod x squared plus 3, in actual fact we don't need the modulus around that anyway. X squared plus 3 is always positive. So we know exactly what this looks like. When x is 0, we have 3, and so it's just the x squared graph which has been translated 3 units vertically upwards. So we can label this, don't really need the modulus, and the domain, well, there's no problem with any real value going in. The range, if we think about our glass elevator coming up the y-axis, then we're going to get real values returned, but only those greater than or equal to 3. So here we have y equals mod x plus 1, x minus 2. Now, that's a quadratic, and the x-intercepts are at -1 and 2. So let's put that onto here. So what we're going to look at first of all is just x plus 1, x minus 2 without the modulus. So -1, positive 2. Now if we expand this out, the x squared is positive. That tells me it's a happy curve. So it's going to do something like this. Now the modulus is going to do exactly the same where the graph is above the x-axis. In other words, where the y values are positive. But having the modulus around this means that we can't return negative values. So what's going to happen is we get the reflection of that part which is below the axis. Now, let's just think we should label maybe this point here. When x is 0, this is 1 times -2, so -2, take the positive value, is 2, like so. Now, no problem with input, all real values can go in, so that's the domain. For the range, y is a real value, and we actually get a point here on the axis and a point here, and every other point is above, so y is greater than or equal to 0. So now we have y equals mod tan x. Now clearly this is a graph that goes on forever, but we just need to show some of it. So let's think about the asymptotes of tan x. So we'd certainly have an asymptote here at pi by 2. We'd have one here at -pi by 2. So one limb of our tangent function comes up here through 0 and then up there, like so. Then if we have x equals 3 pi by 2, which is the next one, I need to write that neater than I have, so 3 pi by 2. Of course over here we'd have x equals -3 pi by 2. Then we have a limb that comes like this, and we have another one that comes like this. And of course the tangent graph repeats itself over and over infinitely in both directions. So this here is at negative pi, this is at 0, and this one is at pi. So the modulus is going to do this, it's going to follow it where it's above the axis, and where it's below it's going to reflect upwards. So same sort of thing here, it's going to go up the asymptote there, through the origin, and then up the asymptote over here, and the same sort of thing here and up there. So the red one is mod tan x.